Hey, hello everybody. Good morning to people in America. Thank you for joining us for this webinar, which is really looking at how to do enterprise scale ETL for Neo4j. How we could load data easily and quickly into Neo4j and try and get past some of the problems that the existing solutions, good as they are, still present us with. So a little about me. My name is Bickers. I'm a principal consultant at GraphAware. And for my sins, I'm also one of the primary authors of the Neo4j OGM library. One of the things that I've been involved in for a very long time, ever since I started working with Neo, is the problem or the issue of trying to get data quickly and easily into Neo4j. And it's almost become an obsession with me, I think. I've got other obsessions, but we won't talk about those. So today, what I want to do is to talk about what sort of challenges are presented when we're trying to import data into Neo4j, the common kinds of challenges people face, what options we have to get around those problems, and one of which, of course, is our own product from GraphAware, Databridge, and we're going to look at the core features of that. And then when we've done all that, I want to do a quick demo. 4 or 5 or maybe a few more different demos trying to show the different capabilities of Databridge under different circumstances with different data sets and so on and so forth. Okay, so let's get started. So these, I think, are probably the most common challenges people face when they're trying to import data into Neo4j. And I'm not talking about the odd CSV file here and there. I'm talking about when you actually have a fairly large problem of data that needs to be ingested. Either you've got lots of different data sources that you need to load into Neo, or you've got non-tabular data, as well as CSV files, for example. You've got other types of data. You need to do data conversions. You need to do some filtering. You want to exclude some data items or exclude some properties from nodes or relationships and so on and so forth. There's also the problem of how do you handle updates when you have duplicate data. This is always a big issue when you've got multiple data sources. Sometimes you've got SQL queries that return duplicate rows, and you need to know that you're not creating the same node many times in the database, for example. There's also the problem of how you do bulk load, how fast you can be with bulk load, and then, of course, having loaded your initial data set, maybe you want to do incremental updates. So this is sort of offline, online paradigm where you do your basic offline load to a quiescent database without the Neo4j server running. And then maybe you want to do updates when you're online, small updates and so on. One of the big issues, of course, is performance, particularly with very large data sets. You don't want to spend 4 weeks loading 100,000 rows of data. And I think one of the most important things as well is how easy any tooling is to use and to configure. So to me, these are over the many years I've been loading data into Neo4j in various different forms. These seem to me the common challenges that we face, and we face them over and over again. And so when it comes to looking at our options, I think we've got a number of different solutions, some of which are from Neo themselves, and some of which are from third-party providers of integration components. That includes Cypher, Load CSV, the Neo4j batch importer, the new stuff from Neo4j, which is the JDBC ETL, plus the APOC libraries for loading data from JDBC data sources. And then the third-party things like Talend, Apache Camel, and so on. There's also, of course, the option of DIY, which in many cases we found ourselves doing, which is one of the reasons why we ended up at GraphAware writing Neo4j Databridge, because we kept reinventing the wheel over and over again. So I'm just going to quickly run through each of those options very briefly, and this is my take on the strengths and weaknesses of each of these different options. You may disagree, and feel free to disagree, of course, but this is what I think. So Load CSV is extremely flexible. Because it's using Cypher, you can pretty much do anything you want. The difficulties with it, I find, are that it's obviously only for CSV files. It isn't really suitable for very large data sets. You also need to know Cypher, and I think that's an important issue when it comes to looking at the types of people who are going to be ingesting data into databases, into Neo4j. Having to learn Cypher, particularly when it's difficult to manage complex imports because of things like trying to do conditional properties, conditional labels, and so on and so forth. It becomes quite difficult to write that Cypher, and you have to be pretty much an expert, I think. It's also relatively slow, which is natural. You know, Cypher isn't going to be the fastest way you can get data into the database. That doesn't mean it's poor performance, but when you're looking at hundreds of millions of rows of data, you probably don't want to be looking at using load CSV for that. Another option provided by Neo themselves is the Neo4j batch importer, which is extremely fast. It uses multi-threads. It can handle extremely large data sets. And it's kind of like the opposite of, in a way, of load CSV, where load CSV gives you massive flexibility. The batch importer almost is the opposite. You can't really do very much with your data once it's been being loaded by the batch importer. And because, in fact, it requires your data sources to be pre-processed first. So, for example, if you have a bunch of data files, maybe in Excel spreadsheets and things like that, you'll need to export those out to different nodes and relationship files, and then run the batch importer against those different nodes and relationship files. So in that regard, it's a little bit inflexible. And the other thing about it, I would say, is it doesn't have any memory. What I mean by that is, if you load something through the batch importer and you come across the same record again, you don't know what to do. There's no way to tell the batch importer, oh, in this circumstance do this, in this circumstance do that, and so on and so forth. So it really has got no knowledge of what's already happened while it's loading data. One of the latest things that's come out from Neo4j itself is the JDBC ETL tooling, which is very fast. What that does is it goes and reads a JDBC database schema and generates mapping files from which it then loads using the batch importer. One good thing about that is that these mapping files are configurable. And so this is a good step in the right direction, I think. Obviously, one of the things against it is that it's a tool just for JDBC data sources, in the same way as load CSV is just for CSV files and so on. And if you're using the APOC library, you need to write Cypher queries. And again, you have the problem with you don't have any memory. You run, because it's using the batch importer in the background, you don't know how to handle duplicate data or different conditions and so on, like I mentioned earlier. But I think all these three tools together, the Cypher side, the JDBC side, and the CSV, are kind of like moving everything in the right direction. But they're still all very differentiated and very different. And if you want to have something under one roof, until now, you couldn't do that. With Databridge, we think you can. But let's talk about the others first. Let's look about Talend. I don't know if anyone's ever used Talend. I haven't, but I have had a look at it, tried to use it. I've never used it in anger. It's a very pretty interface, drag and drop and all the rest of it. It's part of a full ETL platform, so it's very well supported. But it's not very modern in terms of Neo4j today. You're using Cypher queries over the REST API, or you can use an embedded graph database. In this regard, I would say load CSV is much better than the offering currently from Talend. That's my opinion. Okay, someone's telling me I've lost my. Can people still hear me talking? Okay. The other thing about it is, yeah, cool. Okay.
You're good.
Yeah, good. Okay, so the other thing I get about it as well is, similarly, because the way it works, it doesn't have memory. You can't really put stuff into it to tell it what to do with if a duplicate record comes up and so on and so forth. It's more complicated to handle. Apache Camel is something I was unaware of until the other day when I started looking at alternatives to load CSV and so on and so forth. And as a consequence, I can't see anything that's particularly for it. That doesn't mean there won't be anything for it, but it's actually not available yet. And when it does become available, it's planning to use Spring Data Neo4j as the transport mechanism into Neo, which, as one of the authors of Spring Data Neo4j, I would say is not necessarily a good use of that particular tooling. Spring Data Neo4j is not really an ETL tool. I know people have tried to use it as such, but we'll see what happens in that space. That's something to watch, the Apache Camel thing. And of course, the final solution everyone goes for is actually nothing works, I'm going to DIY, I'll do it myself. And of course, the good thing of that is you do have total control. You can do whatever you like. You can create whatever you need in the database, create indexes, and do the rest of those things. But against it, it's time consuming, and it's hard work to get it right. You know, you always find, oh, I forgot to do this, I forgot to do this, I forgot to do that, and so on. So that leads us to the fact that we were keeping on doing DIY all the time with clients we went to, and we found ourselves repeating the same steps over and over again. And so we thought, why are we doing this? Why not create a tool that can do all of these different things, that can handle all these different problems as best as it can under one roof, and try and bring together all the best practices that we've learned from Load CSV, that we've learned from the JDBC ETL, and so on and so forth, and put them all under one roof. And that is Databridge. And these are the features which I believe make Databridge a very compelling alternative to all the other data ingestion tooling that's out there. The first is that it's not programmatic. In fact, you simply define your data resources and your mappings using JSON files, which means that anybody who can write a JSON file can use it. You don't have to know Cypher, you don't have to know how to write SQL queries or anything else like that. Secondly, it's got a very helpful command line shell, which gives you lots of hints and tips as to how to do things. And also we have lots of adapters for many common data formats, so CSV, JSON, etc., etc., etc. We also do direct auto import from JDBC databases. We'll see one of that example working in the demo later on. There's also a fully featured expression language, which is part of the JSON files, which you can put in there, which is basically allows you to filter on nodes, properties, relationships, labels, and so on and so forth, to say what you want included and the conditions on which you want those things included or excluded. There's also a big range of data converters, strings to dates, dates to strings, and so on and so forth, numeric data conversion, sealing, float, and all the other things you might expect, really, sort of small math library and data conversion library. We also support full and incremental imports, and by that I mean, and not only just online and offline, but also we remember what you've done. So if you are in the process of streaming consistent sets of data every day, let's say into Neo4j, we'll remember what you've done, and we won't push the same stuff twice. The other thing that we do is we've got both offline and online endpoints. So you can do a bulk load of a lot of data quickly into the graph offline, and then you can do streaming online into the database while it's still running. Finally, we've made Databridge extensible. So if there's an adapter that you need and you haven't got one for it, and there isn't one for it, for the thing you want to do, you can write your own using the adapter API, just drop it into the lib directory and it will be picked up. Similarly, with any kind of data conversion or other scripting that you want to do, you can write Groovy scripts and drop them into the bin directory, and then you can use them directly in your resource mapping files. Okay, those are the core features, I think, of Databridge. There's a lot to talk about, and we don't have time today to talk about everything. But what I want to do now is to switch across to a few live demos. And these 6 or 7 demos are meant to basically showcase some of the different capabilities of Databridge. We're going to be bulk loading some CSV files. We're going to be streaming some Excel into a live database. We're going to look how to do structured data with JSON files rather than just tabular format. We're going to do an auto import from a MySQL database of some employee data. And then we're going to look at other non-tabular data formats like TomTom itinerary files, ITN, for which there's a built-in adapter, some UK aviation waypoints, which are GPX, for which there's a GPX adapter, which comes. So any GPX files you can use directly. And then finally, we've got a large data set, 500 million rows of data, which represents telephone calls between individuals, between 2 phones. And I'm not going to load it all because we won't have time, but we're going to load, the challenge is to load 9.4 million nodes and 5 million edges in 1 minute. And that's about 5 million rows of data from that data set. So let me see if we can get these demos running. Oh, good. Okay, so the first one we're going to run is the satellites demo, and each of these demos, the way I've set this up, I've done a little script for this. Each of these is going to show us the original data set, show us the mapping files that are being used in order, and then we're actually going to run the import, and then look at the data in Neo4j. So we'll quickly do this one. So here's our satellites data. You can see we've got a number of 11 or so satellites, and you can see the column names across the top: object, orbit, alt, program, manned, launched, status, and so on and so forth. It's a very small set of data, but what we want to do is look at the mapping file for this. So this is the mapping file, and this is the first thing you'll notice when you see all these different mapping files. They are identical in format. You declare it right at the top, you declare your resource that you're going to be using, which case is a satellites file. And here you specify which node types you want. You've got satellite here, you've got space program, we want an orbit node type and a location. And in addition, you have some conditions. I talked about the fact that you could specify whether you want nodes and things included. Conditions allow you to do that. So in this particular case, we're saying I'll create satellite nodes unless the field in the input called alt is equal to HEO, in which case I want to skip that one. There's other conditions here. So on this particular thing here, I'm going to create a label only on the space called space station if this particular row of data attributes manned is true, which is yes, and the status is 1, and so on. Here is a converter. So we've got a launch date column here, which we're creating from an original format which looks like this, and we want to create an ISO 8601 date from that, so that it's machine sortable but human readable as well. Here's another condition showing wildcards or regular expressions. So we want to create a property on this node satellite whose value, his name is historic, and his value will be yes on condition that the object is some kind of Sputnik satellite. And if we don't find that match, we want to create the historic value should be set to no. We have a default value otherwise. There's a few other bits and pieces in here, but we probably won't need to talk too much about that. That would be here for a long time. Right, okay, so we're going to run this import now. And now we're going to have a quick look at the data. And we look at these satellites. And pick up Hubble. And we can see our data has been imported. It's in a low Earth orbit, etc., etc., etc. And you can see we've got some properties on our edges here. We've got properties on our nodes as well. So it looks like it's done what it was meant to do, which is good. Okay, so I'm going to run the next one now. So we'll flip out of there and have a look at the demos. The next one is the charities demo. So the interesting thing about the charities demo is this is a Excel spreadsheet to start with. We'll just get it loaded to start with. There we go. This is the Excel spreadsheet it's going to be loading from here. And we have this is the mapping file for that spreadsheet data. It's very similar to last time. Exactly the same structure. We've got nodes there, and we've got some edges we want to create. Now, interestingly, this particular one, the reason I've shown you this one specifically is not just because we are using Excel, but also because here the names of the edges that are being created, the relationships that are being created, are not constants. They're actually being taken from the column values or the column header values, or rather the actual values of the row themselves for each of those columns. So this is where you want you want to use that a property that's in your data as an edge type. You can do it like this. It's called a dynamic edge, and you can do the same thing with node labels. You can have dynamic node labels as well. So that's just something interesting to show you. We'll load this data now. Each of these data sets is being loaded into a completely different graph database on disk. You can see the old one is there, and this is the new one. We'll have a look at some charities. Let's have a look at Friends of the Castle, provides school provision for children, and these other charities provide other things for children as well. So the New Life Foundation provides, what's that, government policy, medical equipment, and research for children that are in all these different, have different problems like this. So that's really just to show you that the import has worked. We'll move swiftly on and have a look at the next one. This next one is the Olympics, and this is using the streaming endpoint. So rather than going to a database which is offline or quiescent, this is going to running into a live Neo4j database, which we should see. This is the data. This is JSON data. So this is using the JSON adapter, and these are the rows of data. We've got about 40 days, I think 28 or 30 probably, different records of Olympic athletes participating in different sports from different countries. I'm going to create a graph of those. We're going to look at, this is how that mapping file looks. So again, we've got Olympics, athletes, countries, teams. Now, an interesting thing that's here, if you'll notice when we come down to medals, if we look at the data set itself, you'll see it's got these things called gold, silver, bronze, with numbers on them. There's no such, we want to create a gold medal, effectively, node for these things. We want to put a count on it. But what we need to do in this case is, because there isn't any kind of property that we can call to create the identity for this thing, we can instead use values. So here we've got a set of values, and these are like constants that you can use. So I've got gold medal, the name of a constant here, and its value is going to be gold. So that when this identity for this object is created, it'll look first of all in the input source for something called gold medal, and it won't find it because there's nothing called gold medal. But then it will look in here and say, okay, you've got a value called gold medal, and this is the value, and it will use the constant value for that, and it will concatenate that with these other attributes from the input source to create a unique identity for this particular gold medal in this sport, in this year, for this athlete. The other thing we want to do is we don't want to create any medals unless the person actually won a medal of that color. So we don't want to create gold medal unless he or she has won any gold medals. And the other thing we want to do, we could do either on this node or on the relationship we look at in a minute. We want to create we're going to just count the number of gold medals won at this particular competition. The same is true for silver and bronze. They work the same way. And in our edges, we've got a lot of edges. Teams are representing countries, teams participating in the Olympics, an athlete member of a team. And then these various athletes are winning gold, silver, and bronze. And here, what will happen here, unless a node of this type has been created while this row has been processed, this edge won't be created, obviously. So if no bronze medals were won by this athlete at this particular competition, this row here, this edge will not get created in the graph. Okay, so let's run this one. And the other thing I would to say is that this has automatically detected the adapter to use from the file type. So there's a couple of things that gets used. The file extension is used to detect, and also any protocol like JDBC or HTTP as well to ensure the right transport's used as well. Okay, so let's pick up a athlete, Missy Franklin. She was in the 2012 Olympics, and she won bronze. She won 1 bronze, and she won 4 golds at the 2012 Olympics. At the same time, Michael Phelps was also a member of that swimming team, and he won a lot more medals, obviously. 8 golds, 2, etc., 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 at various different competitions. So he's got gold in this one. This one presumably is that's a different Olympics. That's the 2004 Olympics. So this just shows how easy it is to load this data. Quite a complex graph, easily expressed in that way through the mapping files. The next demo I'm going to show you is the empdb one. Now this is a this auto-creates the data by reading a MySQL database and auto-creates those mapping files. And that's the first thing we're going to look at. One of the things that it does is, there we go. So it's read a JDBC, it's done some JDBC auto configuration, and it's read the JDBC schema, and it's created the Databridge schema for the various tables and so on in the SQL database. And in this particular case, it's also decided on some strategies regarding join tables. There are a number of join tables in this database, and it's decided that in some cases, in fact, in all cases in this particular one, they'll be better represented as a direct join between nodes, a direct relationship between two nodes rather than an intermediate node. And there's a number of heuristics it uses to determine that, which we won't go into now. But here's the first of those things. So it creates a resource for each of the tables that it comes across, including the join tables. And the mappings are the nodes and the properties and so on. And you'll notice that in this particular case, it's only interested in loading nodes. There's no edges at this point. It says, right, I've got the departments. And the other thing it does is figure out the best order in which to load things. And this is its order, it's decided. Then it's got the employees and departments, which is reading from a join table, and it's creating just an edge from source to there with some properties on them from date and to date. And then the same thing with employees, and it's reading there some management resources, yes, which employees are managers in this case. And finally loads the employees table as well and puts all the properties in. Oh, some salaries data as well, and titles, blah, blah, etc. Okay, so let's go and see what happens. We'll run this one. This is actually quite a lot of data, and I've limited it for the purposes of this to about 1,000 rows of data, or 1,000 records, I should say. So we've loaded that data now. Now, let's have a look at this. And let's pick an employee, Warwick. And there he was. He was an engineer. He had different salaries at different times. He was a member of the production department, and these other guys were also members of the production department at the same time. Now, obviously, the names it's chosen for these edges are basically based on the table names, the join table names that existed there. The point about creating the mapping files as an intermediate step is that you can then, if you want, to change those things before you actually run the import. I didn't bother at this point. But then this will work with MySQL, Oracle, basically any JDBC data source that you've got. You'll need to supply your own driver, and you just drop it into the lib directory, and it will detect it and use it. So that's that. The next one I want to have a look at is some non-tabular data. So this is the Isle of Man TT course. I'm a keen motorcyclist, so this is of great interest to me. I'm going to have a look at the data first of all. So this is TomTom itinerary file format. The first columns are the latitude and longitude in hundreds of thousands of a degree. Then there's the name of the point of interest, and then what kind of point it is. It's a start point, a 0 is a waypoint, and in this case, pit lane is the end point. And it's also the start point as well, you'll notice. So things can have more than one value. Now, what we're doing with this particular itinerary is, because it's an itinerary, we're trying to create a route in the graph. And basically the ITN adapter understands that it's got to basically make a join between pit lane and Douglas, and then Douglas and St. John's and Kirkmichael, and so on and so forth. So this is automatically handled for you by the ITN adapter. So we're going to see that running now. We'll just have a quick look at this. So we're creating 2 points of interest. You'll notice POI.1 and POI.2. And the reason is because actually this is we need to make sure that when we create the edge between these 2 points of interest, we can identify which one we're doing. So they're suffixed 1 and 2, and this is a standard way of doing an edge between two objects which have got the same type in effectively the same row of data being imported. So we'll run that now. And we'll have a look at that. And there's a lovely little graph. So we start at Pitt Lane, we go to Douglas, we go to St. John's, Kirkmichael, and then Churchtown, and finally back to Pitt Lane. So obviously you could do this with any kind of itinerary. You can create route tube maps and things, and use if you put them as an ITN file in format, you could then actually create a route in the graph like this. There are obviously other things you can do, and if you want to write your own adapters, you can do that as well. But this is a very simple way of getting, say, for TomTom itinerary data in. The next thing I want to show you is similar. This is GPX data, which is navigation data, effectively, and it's in XML format and specific XSTD. So this is nav8. So let's see if we get nav8 coming up. Yeah. So this is all the UK navigation waypoints, VORs, DMEs, airports, NDBs, and so on and so forth, in TACANs as well. So not only commercial, but also military waypoints in here as well. And so as you can see, this is XML. So we have a GPX adapter built into Databridge, Neo4j-Databridge, which can handle GPX data automatically, detect it, and use the right adapter. Let me find. We go back to here. Yeah, so we're now going to run this one. So very similar sort of thing before this. We're creating waypoints, tracks, track segments, and routes, and so on and so forth. And we're going to create a graph. Let's have a look at, and there they all are. So we've got all these different waypoints loaded in the graph like this. Okay, so far so good. I've tried to show you lots of different capabilities in terms of what the adapters that are supported, the different data types that are supported, and so on, so data formats as well. The last thing I want to do is to show something, a little bit of the sort of performance aspect of Databridge. And this is going to be the Hawkeye data, which I had talked about before. As I said, it's 500 million rows of data, and we're going to load 5 million rows. And the challenge is to do it in less than a minute. I haven't talked about the profiling, but we'll talk about that. Basically, the profiler runs before every data load in order to optimize the actual data load itself. It works out the average key length, the maximum number of records of any particular type of node and any particular kind of edge. So this will take, hopefully, just about 1 minute to run. And what you'll notice is while you're looking at this, I don't know how easy it is to see. Maybe if I just make it a little bit bigger, it might help. You'll see that the number of nodes and edges is going up, and the rate at which objects are being created in the database is also shown there. So 200,000 objects a second at the moment, with about 70,000 rows being processed every second as well. Some of these data rows are duplicates, not very many in the first 5 million. So we'll just let that run to completion. And hopefully it will be done in less than a minute. At the end of every import, if you've specified indexes to be created, as I have here, we'll create some indexes. Oh, 1 minute 12. Oh, I failed. Every time I tried this before, it was 58 seconds. There we go. Index creation is happening now. And this is Lucene indexing going on behind the scenes. So we got about 14.5 million objects in the database, and we're now just creating the indexes on those phones. Demos always go wrong, eh? There we go. Okay, so that's going to finish in about the same amount of time, actually, as it takes to load the data. So I'm not going to bother waiting for that. for now. That's really everything I had to show today in this webinar. So I'm opening up for questions to anyone who wants to ask anything or not sure about how things work or so on.
All right, great. Thanks, Vince, for that amazing presentation. We do have a question, and just to let the audience know, we'll send you the recording of today's presentation as well as the slides to the email that you used to register. And you can submit any questions that you have using the questions box on your GoToWebinar control panel. And we'll take as many as we have time for. So the first one is, can we have dynamic edges with variables like current date or a concentration of 2 CSV column values? That was a tongue twister.
Can we have so the answer is no. So I see what you're saying. So can I create an edge from two values, an edge type from 2 values, a relationship type from 2 values? In theory, yes. There's nothing actually to prevent that from happening. It's not supported right now, but if we need to do that, it's easily supported. So the answer is not right now, but there's nothing in the architecture that stops us from doing that.
All right. And then our next question is it easy to change from a run to a stream schema, and can I reuse the same schema?
Absolutely. Yeah, the only difference, in fact, to the import is the fact that you just specify that you want to use the streaming endpoint. And if I didn't show you any of the basic commands here, but maybe I will just quickly. Which demo do I want to run? None of them. So if I say in Databridge import demo satellites, let's say, which is one of the ones we run today, then that's going to use the offline endpoint. However, if I say import -s demo satellites, that says I'm going to use the streaming endpoint. I've not changed any of the mapping files, nothing else. I'm just using a different way of connecting or getting the data into Neo4j. So the answer is yes, you don't have to change anything. You just specify the endpoint you want. The default is to use the bulk load endpoint, which is offline. But with -s, you can say, I want to use the streaming endpoint, please.
All right. And I'll wait just one more second to see if anyone else has any questions. All right, here is your next question, Vince.
Oh, good.
Can I combine different sources to create the same node?
Yes, you can. I haven't given you an example of that today, but we have a client who did exactly this. I'll be able to show you. Let me just. Let me show you. So yes. So one of our clients was GoApe. I'm not going to show you any of their data, but they did have a lot of data from different data sources that they wanted to combine. And in fact, we should be able to look at the schema for that. Yeah, so they had addresses that they wanted to merge with client data and so on and so forth. And some of this data was from different address data, or company data was from different sources. The only thing that's necessary is to agree on the identity of a particular piece of data. So if you have a customer called, John Jones or something like that, all sources, all data sources have to agree that this is the same piece of data that they're talking about. We didn't really talk about identities, but the identity of a piece of data that's coming in is critical for Databridge to work. In this case, it's a primary contact ID from some relationship table or some table in a database. But that ID may have been exported as well out to a CSV file, and that CSV file may also be imported. And provided both of those things can say the identity of this row is this thing here, then we can join that information into a single node if we want to. And that's using an update strategy called merge. Normally, you want an update strategy unique because you're only interested in creating the piece of data once. But if you know that you've got effectively a composite object and it's going to be coming from different data sources, you can use the merge strategy, and it will merge on that index, on that identity, and pull all those different properties together and create a node that's a composite of all the different initial data input sets. So the answer is yes, you can.
All right, great. I think that's all the questions that we have for today. So thank you, Vince, for that presentation and for taking those questions. And we'll go ahead and send out the these slides and the recording.
Okay, thank you very much, Corey. Just last thing to say to people, if you're interested to know more, have a look at the wiki, which is on the last slide you should be able to see now. Send us an email, databridge@graphaware.com, or if you just want to ask some general questions, ask us on Stack Overflow, and we'd be very pleased to help you. If you want to know more about Databridge, contact us. If you think it'll be useful for your project, give us a bell, drop us a line, and we'll see what we can do for you. Thanks very much.
All right, thanks so much. Bye.